Hello, my name is Arziman bin Zainurin from Group G, and my group member is Brendan Sanjan anak Linus and Anastasia Delvis anak Lee. Objective and applicable standard to determine the value of liquid limit, plastic limit, and plastic index of soil. ASTM D4318 is a standard test method for liquid limit, plastic limit, and plasticity index of soil. Purpose of measurement. This lab is performed to determine the plastic and liquid limit of fine-grained soil. The liquid limit is arbitrarily defined as the water content in percent at which a part of soil in standard cup and cut by a groove of standard dimension will flow together at the base of the groove for 13 mm. When subjected to 25 shock from the cup being dropped 10 mm in a standard liquid limit, apparatus operated at a rate of 2 shock per second. The plastic limit is the water content in percent at which a soil can no longer be deformed by rolling into 3.2 mm diameter threads without crumbling. The apparatus that we use is liquid limit device, grooving tool, spatula, soil specimen, moisture cans, and glass plate.
Now we move on to procedure. Sieve the soil by using number 40 sieve and take roughly 3/4 of soil and place into the porcelain dish. The soil is mixed with small amount of distilled water until it appears as a smooth, uniform paste. 4 moisture cans are weighed and recorded the respective weight and can number on the data sheet. The liquid limit apparatus is adjusted by checking the height of drop of the cup. The point on the cup that come in constant with the base should rise to a height of 10 mm. The block on the end of the grooving tool is 10 mm high and should be used as a gauge. Use a cup by practicing and determine the correct rate to rotate the crank so that the cup drops approximately 2 times per second. Place a portion of the previously mixed soil into the cup of the liquid limit apparatus at the point where the cup rests on the base. Squeeze the soil down to eliminate water pockets and spread it into the cup to a depth of about 10 mm at its deepest point. The soil pad should form an approximately horizontal surface. Carefully cut a clean, straight groove down the center of the cup by using the grooving tool. The tool should remain perpendicular to the surface of the cup as groove is being made. Use the extreme care to prevent sliding the soil relative to the surface of the cup. Make sure that the base of the apparatus below the cup and the underside of the cup are clean of soil. Turn the crank of the apparatus at a rate of approximately 2 drops per second and count the number of drops it takes to make the 2 halves of the soil pad come into contact at the bottom of the groove along 13 mm. If the number of drops exceeds 50, then go directly to the step 8 and do not record the number of drops. Otherwise, record the number of drops on the data sheet. Take a sample using a spatula from edge to the edge of the soil pad. The sample should include the soil on both sides of where the groove came into contact. Place the soil into a moisture can cover it. Immediately wave the moisture can containing the soil, record its mass and remove the lid, and place the can into the oven. Leave the moisture can in the oven for at least 16 hours. Place the soil remaining in the cup into the porcelain dish. Clean and dry the cup on the apparatus and the grooving tool. Remix the entire soil specimen in the porcelain dish. Add a small amount of distilled water to increase the water content so that the number of drops required to close the groove decrease. Repeat steps 6, 7, and 8 for at least 2 additional trials, producing successively lower number of drops to close the groove. Now procedure for plastic limit. Weigh the remaining empty moisture can with the lids and respective weight, and can numbers be recorded on the data sheet. Remaining quarters of the original soil sample is taken and added with distilled water until the soil is at consistently where it can be rolled without sticking to the hand. Form the soil into an ellipsoidal mesh. The mesh between the palm or the fingers and the glass plate is then rolled. Use sufficient pressure to roll the mesh into a thread of uniform diameter by using about 90 strokes per minute. A stroke is one complete motion of the hand forward and back to the starting position. The thread shall be deformed so that its diameter reach 3.2 mm, taking no more than 2 minutes. When the diameter of the thread reaches the correct diameter, break the thread into several pieces. Knead and reform the pieces into ellipsoidal meshes and re-roll them. Continue this alternate rolling, gathering, kneading, and re-rolling until the thread crumbles under the pressure required for rolling and can no longer be rolled into a 3.2 mm diameter thread. Gather the portion of the crumbled thread together and place the soil into moisture can, then cover it. If the can does not contain at least 6 grams of soil, add soil to the can from the next trial. Immediately weigh the moisture can containing the soil, record its mass, remove the lid, and place the can into the oven. Leave the moisture can in the oven for at least 16 hours. Repeat step 3, 4, and 5 for at least 2 times. Now we move to the calculation and data. For the liquid limit, the water content for the first test is 20%, second 40%, 3 66%, 4 75%, and 5th is 80%. From the liquid limit chart, we can determine that the liquid limit is 67% in the 25 number of drop. And for the plasticity index, plastic limit, the average that we are getting is 40.75%, and the plasticity index is 26.25. As for the report, liquid limit is 67%, plastic limit is 41%, and the plasticity index is 26%.
Safety and precaution. Soil used for liquid limit determination should not be over-dried prior to testing. Wet soil taken in the container for moisture content determination should not be left open in the air. The container with soil sample should either be placed in desiccator or immediately be wet. For the conclusion, the importance of the ATTERBERG limit test is to classify soils. Different soils have varying liquid and plastic limit. The subject of the study is ATTERBERG limit that is empirically determined, state at which a transition of a softly plastic to liquid state occurs. Therefore, after its achieving, soil start to behave as a liquid substance. The ATTERBERG limit measurement is principal especially for finding consistency state playing a decisive role for determining the key standard characteristic of soil representing important geotechnical parameter of line grade soil for investigation of so-called first geotechnical category. In conclusion, before realization of the test, the sample set up for 24 hours for the purpose of even distribution of moisture.